Space is big, really big. Imagine the biggest thing you can. Now multiply that by infinity. That's the observable universe, a vast expanse stretching 93 billion light-years across. It's filled with billions upon billions of galaxies. And each galaxy, home to billions of stars, many orbited by their own families of planets. We, on our little blue planet, are just one tiny speck in this cosmic ocean. We've only explored a tiny fraction of our own solar system, yet we yearn to know, are there other Earths out there? What strange and wonderful worlds await our discovery? The quest to understand planets beyond our own is a journey into the unknown. It's a journey driven by curiosity, by a desire to unravel the mysteries of the universe. And it all starts with a single question: what kinds of planets are out there? Planets are like cosmic snowflakes. Each one is a unique masterpiece crafted by the universe over billions of years. Just as no two snowflakes are identical, no two planets are exactly the same. They are all distinct in their own ways with their own stories to tell. No two are exactly alike. Each planet has its own unique characteristics, from its size and composition to its atmosphere and orbit. Some are small and rocky, while others are massive and gaseous. Some have rings while others have moons. The diversity is truly astounding. They come in a dazzling array of sizes, compositions, and personalities. Some planets are scorching hot, while others are freezing cold. Some have thick, swirling atmospheres, while others have thin, wispy ones. The variety is endless, and each planet is a world unto itself. Let's meet some of the key players in this cosmic dance. Each type of planet has its own unique characteristics and plays a different role in the grand scheme of the universe. From the rocky terrestrial planets to the massive gas giants, each one is a marvel of nature. First up, we have the rocky planets, also known as terrestrial planets. These are the solid ground planets like Earth, Mars, Venus, and Mercury. They are made mostly of rock and metal with thin atmospheres. These planets are the closest to the Sun and have a solid surface that you could stand on. These are the solid ground planets like Earth, Mars, Venus, and Mercury. Each of these planets has its own unique features. Earth, for example, is the only planet known to support life. Mars has the largest volcano in the solar system, while Venus has a thick, toxic atmosphere. Mercury, the smallest of the four, has a surface covered in craters. They're made mostly of rock and metal with thin atmospheres. These planets have a solid surface and are composed primarily of silicate rocks or metals. Their atmospheres are thin compared to the gas giants, and they have fewer moons. Despite their similarities, each terrestrial planet has its own unique characteristics and history. Next, we have the gas giants, massive planets like Jupiter and Saturn. These behemoths are mostly hydrogen and helium with thick, swirling atmospheres and no solid surface to speak of. They are the largest planets in our solar system and have a multitude of moons and rings. These behemoths are mostly hydrogen and helium, with thick, swirling atmospheres and no solid surface to speak of. Jupiter, the largest planet in our solar system, has a great red spot, a giant storm that has been raging for centuries. Saturn is famous for its stunning rings, made up of ice and rock particles. Think of them as giant, gassy clouds. These planets are composed mainly of hydrogen and helium, with no solid surface. Their atmospheres are thick and turbulent, with powerful storms and high winds. Despite their size, they have a low density, and are mostly made up of gas. Then there are the ice giants, Uranus and Neptune. These planets are similar to gas giants, but have more icy materials like water, ammonia, and methane in their atmospheres. They are smaller than Jupiter and Saturn, but still much larger than Earth. They're similar to gas giants, but have more icy materials like water, ammonia, and methane in their atmospheres. Uranus is unique in that it rotates on its side, while Neptune has the strongest winds in the solar system. Both of these planets have a blue hue due to the presence of methane in their atmospheres. But wait, there's more. Beyond our solar system lie exoplanets, planets orbiting other stars. These alien worlds come in a variety of sizes and compositions, and some may even be capable of supporting life. The discovery of exoplanets has opened up a whole new field of astronomy, and has expanded our understanding of the universe. We've found thousands of these alien worlds, some potentially like Earth. These exoplanets vary widely in size, composition, and distance from their parent stars. Some are rocky like Earth, while others are gas giants like Jupiter. The search for exoplanets continues, and each new discovery brings us closer to finding a world that may be similar to our own. Among exoplanets we have super-Earths, larger than Earth but smaller than Uranus or Neptune. These planets are of particular interest because they may have conditions suitable for life. Super-Earths are rocky planets with a mass higher than Earth's, but lower than that of the ice giants. They may have thick atmospheres and liquid water on their surfaces. And then there are rogue planets, drifters roaming the galaxy without a star to call their own. These planets have been ejected from their parent star systems and wander through space alone. Despite their isolation, rogue planets may still have atmospheres and even moons. They are a testament to the dynamic and ever-changing nature of the universe. The universe is full of surprises. From the diverse array of planets in our own solar system to the countless exoplanets orbiting distant stars, the cosmos is a place of endless wonder and discovery. Each new finding adds to our understanding of the universe and our place within it. The journey of exploration continues, and who knows what we will discover next. What are planets made of? Have you ever wondered about the incredible diversity of planets in our universe? Well, it's like baking a cosmic cake. Just as a cake requires a variety of ingredients, so do planets. You need different ingredients in different amounts. Each planet has its own unique recipe, combining elements in specific proportions. Rocky planets are like dense, chewy cookies, mostly made of rock and metal. These planets are solid and heavy, with surfaces that can be rugged and mountainous. They might have a metallic core, a rocky mantle, and a thin crust. This layered structure is crucial for their stability and geological activity. Earth, for example, has a molten iron core that gives it a magnetic field, protecting us from harmful radiation. This magnetic field is essential for sustaining life as we know it. Gas giants, on the other hand, are like giant cotton candy puffs. These massive planets are composed mostly of gases and have very different characteristics from rocky planets. They're mostly hydrogen and helium, the lightest elements in the universe. These elements give gas giants their low density and immense size. They might have a small dense core, but most of their mass is in their thick, gaseous atmospheres, filled with swirling clouds and powerful storms. These storms can be incredibly intense, lasting for centuries. Ice giants are like a hybrid, a bit of cookie, a bit of cotton candy. They have characteristics of both rocky and gas planets, making them unique. They have more heavy elements and ices than gas giants, giving them their bluish hues. These ices include water, ammonia, and methane, which contribute to their distinct appearance. Their atmospheres are still thick and dynamic, with powerful winds and strange weather patterns. These weather patterns can include supersonic winds and massive storms, making ice giants fascinating subjects of study. Section 4. Sizing up the universe. A matter of scale. Size matters in the universe, especially when it comes to planets. Rocky planets tend to be the smallest, ranging from tiny Mercury to slightly larger than Earth super-Earths. Gas giants are the behemoths of the planetary world, with Jupiter, the largest in our solar system, dwarfing all other planets. Ice giants fall somewhere in between, but size isn't everything. Density also plays a role. Rocky planets are dense, packed with heavy elements. Gas giants, despite their size, are surprisingly fluffy, with densities closer to water. Ice giants are denser than gas giants but less dense than rocky planets. The size and density of a planet affect everything from its gravity to its atmosphere to its potential for hosting life. A planet's size and makeup are clues to its history and its role in the grand cosmic symphony. Section 5. Seeking life's cradle, the habitable zone and beyond. We humans are obsessed with finding life beyond Earth. But where should we look? One key concept is the habitable zone, often called the Goldilocks zone. This is the region around a star where temperatures are just right, not too hot, not too cold, for liquid water to exist on a planet's surface. Liquid water is essential for life as we know it, so planets in the habitable zone are considered prime real estate for life. But here's the thing, life is full of surprises. What if life could exist outside the habitable zone? What about on icy moons orbiting gas giants heated from within by tidal forces, or on rogue planets wandering the galaxy alone, perhaps warmed by internal heat or even harboring life in subsurface oceans? The possibilities are as vast as the universe itself. Section 6. Cosmic Detectives Unmasking Distant Worlds. In this section we delve into the fascinating world of exoplanet discovery, where astronomers act as cosmic detectives, uncovering the hidden secrets of distant worlds orbiting stars far beyond our solar system. Finding planets around other stars is like trying to spot a firefly next to a spotlight. The challenge is immense because the stars are incredibly bright, often outshining their planets by a factor of 1 billion or more. Imagine trying to see a tiny, faint firefly right next to a powerful spotlight. That's the kind of difficulty astronomers face. The stars are big and bright, while planets are small and faint. This stark contrast makes direct observation nearly impossible with conventional telescopes. However, the ingenuity of astronomers knows no bounds, and they have devised several clever techniques to detect these elusive worlds indirectly. But astronomers are clever, and they've developed ingenious methods to detect these elusive worlds. By using advanced technology and innovative methods, they can infer the presence of planets even when they can't see them directly. These methods rely on observing the subtle effects that planets have on their host stars. One method is the transit method. This technique involves monitoring the brightness of a star over time. When a planet passes in front of its star, it causes a tiny dip in the star's light, known as a transit. This dimming is minuscule, often less than 1%, but with precise instruments, it can be detected. Just like when Venus passes in front of the Sun, causing a tiny dip in sunlight, a planet passing in front of its star causes a slight dimming of the star's light. By carefully measuring these dips, astronomers can determine the size of the planet and even gather information about its atmosphere. By measuring these dips, astronomers can infer the presence of a planet. They can also estimate the planet's size, its orbital period, and sometimes even its atmospheric composition. This method has been incredibly successful, leading to the discovery of thousands of exoplanets. Another method is the radial velocity method, or the wobble method. This technique involves observing the star's light spectrum for tiny shifts caused by the gravitational pull of an orbiting planet. As the planet orbits, it causes the star to move slightly, creating a wobble that can be detected through changes in the star's light. A star and its planets actually orbit a common center of mass. This center of mass is not exactly at the center of the star, but somewhere between the star and the planet. As the planet orbits, it causes the star to move in a small orbit around this center of mass, creating a detectable wobble. This causes the star to wobble slightly as the planet tugs on it. By measuring the star's wobble, astronomers can determine the planet's mass and its distance from the star. This method has been particularly effective in finding large planets known as hot Jupiters, which are close to their stars. By measuring this wobble, astronomers can estimate the planet's mass and orbit. These methods have limitations. They are most effective for detecting large planets that are close to their stars, but they have been instrumental in expanding our understanding of planetary systems. They're best at finding large planets close to their stars. These planets, often referred to as hot Jupiters, are gas giants that orbit very close to their host stars, making them easier to detect with current technology. But new telescopes and techniques are being developed all the time, allowing us to peer deeper into the cosmos and uncover the secrets of distant worlds. With each new discovery, we get closer to understanding the vast and diverse universe we inhabit, and the potential for finding other habitable worlds continues to grow.